Hello and welcome to today's AWS webinar entitled Journey Through the Cloud. Today we're going to be focusing on development and test and how AWS is a perfect place for performing those functions in your business. My name's Ryan and I'm a technical evangelist and I'll be taking you through that journey today. This is the second in our Journey Through the Cloud series, and the idea behind this series is that we talk about common use cases that are stepping stones into the AWS cloud, enable you to bridge into using cloud services in a way and a pace that suits yourselves, enables you to learn from customer journeys. So these are experiences, technical aspects of AWS that are we listen to in our customer base. Our solutions architecture teams working with customers bring these learnings back to enable you to learn from those best practices and to bootstrap your projects. So with that in mind, today's agenda is development and test. And development and test within AWS is a great place to start consuming cloud services. It's a great place to explore the benefits of AWS with a truly non-production use case. It's a use case that's out of band of your front office or your transactional platforms, and enables you to explore the cloud whilst also getting some benefits from it, namely creating agility in your development and test cycles whilst learning cloud along the way. And enables you to exercise things like elasticity and automation to real advantage as well. You can create some serious agility within your organization by using cloud services as part of dev test cycles. So today's agenda is going to talk about why AWS is such a good place for development and test. We're going to talk around services that can be employed, and we're going to build some patterns in the dev test scenario in terms of the applications that can be deployed, the processes that go on within dev test cycles and how they're married to the AWS services. And we'll give you some ideas of where to go next to find out more information. So let's crack on. So why AWS for development and test? Now I could have put dozens more words on this slide here, but the idea being is that there are many different types of applications that people are deploying. There are many different development cycles or methodologies that people use, and there are many different testing regimes or testing approaches that people employ to ensure their applications have integrity or work at scale and so on. I'm not going to tell you how to do dev test in this webinar, but certainly what I want to do is draw some commonality between all of these different things, whether you're talking about deploying SaaS applications, you're dealing with packaged business applications, you're trying to do certain performance or load testings. There's some commonality between development and test environments. And namely, those common traits are that these environments are typically disposable and that they're very numerous in the quantity that you have in your environments. So what do I mean by that? So disposable environments, typically projects start and stop frequently, or development cycles start and stop frequently, and that those environments that you create to support that are required for a short period of time, so that you throw them away ideally afterwards, because when you recreate an environment you're looking to do something from a known starting point or a golden master. So disposability of an environment is a key aspect, or the cleaning of an environment prior to you starting another cycle is a key aspect of doing rapid development cycles. And numerous because typically there are many environments that support an application. So take an application that is in production somewhere or in production release. You will have many development environments potentially, you will have staging environments, different types of test environments, and you may have a number of development cycles that are ongoing and that are overlapping, and as such the multiplier effect from a single application in production means that you could have dozens of associated dev test environments supporting the development cycle behind that application. The other thing that makes them sort of numerous is that you often need to preserve sort of known configurations of applications. So when you are having overlapping development cycles, you'll want to create entire sets of environments that replicate a particular version set. That might mean associated libraries, associated containers, and so on. So they're very numerous, and we like to be able to throw them away. They're disposable. They're not something that live for many years typically. So development and test in the cloud I'd like to summarize that then in 3 aspects, and we'll talk through these aspects throughout the presentation. So the first reason that AWS and DevTest are such great friends, if you like, is that you can take lots of it when you need it. There is unlimited elastic capacity in AWS. So supporting that numerous side of DevTest environments, you can take as many environments as you like. The other aspect of elastic computing and AWS in the cloud is that you can throw it away when you're done. So you can achieve some pretty significant cost optimizations in development and tests by simply turning stuff off when you don't need them. Now that may be on a daily basis, every evening, or simply when you're done with an environment, just throw it away as soon as possible. And we'll talk about some of that as well in this webinar. And then lastly, preserving it for future reference. An undersung aspect of DevTest in the cloud really is the fact that we have extremely durable storage for storing data and images of machines. So you can take environments and turn them off, dispose of them, but at the same time you can save them as, if you like, freeze-dried copies so that you can recreate them in the future. And this is particularly useful if you need to roll back to a particular version, maybe to solve a particular problem that's occurred in the field or fix a particular type of bug. You can create an environment that is exactly as your customers may have it, for example, in the cloud, and recreate an issue by using durable imaging of machines and the storage of those images in highly durable storage. So let's talk through some of those in turn. So take lots of it when you need it. I'm going to take you through a number of steps here shown on this slide. So starting with the Elastic Data Center, if you like, the fundamentals of AWS and DevTest. Take you through spinning up environments as you need them, some of the methods that people employ to do that. Some of the packaged applications that you can deploy in AWS, which often are very large, cumbersome type applications, and when you make changes in your enterprises to those applications, you need to test those changes, or when you need to upgrade those applications. We'll look at deploying development and test frameworks in AWS, some of the things you can do to aid testing at scale, and some of the tips and tricks that we have for rolling things out into production using some of the unique properties of cloud services. So first off, the Elastic Data Center. This is really an essential part of understanding how to build environments in AWS, and it starts with something called an Amazon machine image down there at the bottom left. And a typical process for somebody to create a custom building block from which to build an environment to support a development environment or a test environment is to take a generic image, AMI, that could be a Windows or a Linux image, to constitute that as an instance in EC2. To then customize that instance, loading things like custom application stacks, might be custom libraries, custom runtime environments to support a particular application type, and then to create an AMI, a customized AMI from that. And that becomes, if you like, your freeze-dried essential building block for an environment. And then using that in the Elastic Data Center, customers will typically have a number of assets on premise. So they're looking to use AWS to extend their on-premise infrastructure for the support of development and test cycles. So taking the on-premise infrastructure, what they're generally doing is then creating an Amazon VPC, so a private section of the AWS cloud. So all resources launched in here by default are not public. And this is useful because a dev test environment is typically an extension of your internal systems, extension of internal workstations. It might be an extension of an internal laboratory data center environment. Within that VPC, you then populate those with instances based upon your customized AMIs that I've just created in the previous slide. So you can create environments within the VPC which you then connect to your premises over things like our dedicated connections or over a VPN connection. And this enables you to burst or to create the environments in AWS as if it was a second data center that you owned and managed. And when you're done with those resources, you turn them off. So back to our 3 points about take lots of it when you need it, throw it away when you don't, and preserve it for future reference. At a very high level, what we've just seen in those diagrams is the fact that you can provision resources based upon some freeze-dried images, and then when you're finished with using, you can throw them away. And it's those concepts that then apply to all the different types of parts of the dev test cycle that we'll go through next. So spinning up environments as you need them. How do people do that? Well, let's look at a customer to start with and how they talk about AWS. We've all probably heard of Little Big Planet, the little character there on the left. A Media Molecule, part of Sony Computer Entertainment, use AWS to run their production platform behind the game. So the massively multiplayer online game, the sharing of goods and stickers and things like that within that game. And one thing I want to draw your attention there is that Alex Evans, their CTO, talks here about loving the flexibility of AWS that allowed them to spin up smaller test environments for beta trials, QA, localization, and during development, and to spin those up on demand as he needed them at a low initial cost. That enabled them to really revolutionize the quality of the games they produced it. So what sort of techniques does he use? There are three main methods that people employ to spin up an environment in AWS. The first is based upon AMIs, snapshots and bootstrapping. So that previous image where you create a custom AMI and then you reconstitute images of servers from those AMIs. So you're using core AWS features to set up an environment to meet your needs. And typically this is, if you like, the starting end of the spectrum. So people will do this through the console using the web interface on AWS. And then maybe they'll move on to enacting that through some simple scripting, where they might have bootstrapping scripts on their AMI which configure an instance to be a particular type of environment. So they might use the console and then using something called user metadata, type in that this is a development environment for application X, and that data will then drive a bootstrapping script on that box to download the appropriate assets and set it up as that environment. And you can have an environment ready for a developer on the back of a request in a few minutes using that approach. A second approach that people use is using something called Beanstalk. Essentially, these are managed standardized containers for developing different types of applications, whether it be PHP, Java, Python, and so on. And these give developers a development and ultimately a test environment direct from an IDE if required. So you can download a plugin for Eclipse or Visual Studio and allow your developers to deploy into a standardized architecture, including load balancing, including auto scaling and databases, that you know that each developer will get exactly the same thing, and you can configure those containers to meet your needs based upon properties or AMIs. Then lastly, customers using CloudFormation, where they have large and complex environments that might have many different third-party aspects to them, whether it's software, architectural frameworks, and so on. And they take advantage of our CloudFormation templating language, where they generate environment specifications essentially as they build software, and when they need to deploy that particular version of the software, the entire environment can be built declaratively from the template. So let's have a look at Beanstalk, because we've already had a quick look at AMIs and how Beanstalk works. So Beanstalk essentially allows you to take an application version and marry it with an application environment, all managed within the Beanstalk framework. So you can deploy an app, a version of an app, from source control into, say, a test environment that's specified with small instances, particular type of auto scaling, and that it lives in a single availability zone. And ultimately you can move that application through environments to a production grade environment. So Beanstalk is a great way in which people start at a dev, move to test, and then can deploy into production using one single framework. Beanstalk supports currently .NET, Java, PHP and Python, and there are more containers coming soon, so do subscribe to our blog at aws.typepad.com to find out as they're released. And a container essentially is somewhere where our web application package runs inside the Beanstalk, and exploding that, we have essentially our user application that deploys into an instance, and on that instance we install an application service, an HTTP service such as Apache, language interpreters, so if this is a PHP, these are mod PHP modules, an operating system, and then a host that we deploy it within the AWS environment. And depending upon the language, the container you choose as part of Beanstalk, you'll get different aspects at each of those layers. But what it does behind the scenes is when you've deployed an application to Beanstalk, say from your Visual Studio environment, We'll create an elastic load balancer. We'll create an auto-scaling group. We'll create some Windows instances or Linux instances based upon the container and launch them into EC2 containing your code. We'll wire those things up onto the Beanstalk framework, and then we'll publish them under a CNAME. So you can then start testing a classic web application, for example. Now we store all the different versions of applications in S3, and we consolidate all the logs across those machines into a single view in S3 and available through the console. And indeed through things like our Visual Studio plugin or our Eclipse plugin, so you can see all this stuff going on direct from the dev workbench. The benefits of this is that a developer doesn't need to configure an environment, because you can specify this environment in terms of the base containers, the machine images being used, or indeed the configuration of those boxes in terms of modules that might be installed to support an application. Moving on to the other end of the spectrum, if you like, in terms of declarative control. Creating environments for development and test, people use CloudFormation, and CloudFormation is a framework that is based around the idea of a template on the left that is loaded into the CloudFormation framework that then generates something called a stack on the right. So a template is simply a JSON formatted file that allows you to define parameters that you might get for user input when you create a stack. Declines the creation of resources within AWS, such as load balancers, security groups, EC2 instances, databases, queues, and so on. And then apply configuration actions to those resources that are created, such as download software and install it on EC2. The CloudFormation framework itself deals with the creation of the stack, how you update the stack when you update the template, and detecting any problems in deployment and rollback. Then the stack itself is a running collection of services. So think of this as it could be your development environment, a load test environment, or indeed a production environment. Now there's some benefits of templated environments, and the first is that you can actually create these things programmatically. And if you think about the AWS environment as a programmable data center, creating the specification of the resources that are required to run a particular application at the time of creating the code has certain benefits. Well, the first is there's no human involvement. The second is that you can source control these things, so it's a known configuration. So each time you produce a version of the app, just as you would source control and be able to do diffs on code and modules, you can do the same with the infrastructure specification required to run it. Another thing is they're parameter driven, so you can create these things as dynamic and user driven templates. So you might have a standardized template that when it's fed with the parameter, this is a dev environment, for example, and the drop down list within the console, that might drive a certain configuration of resources. So it might drive a single instance configured to run an environment. Whereas if you dropped in a parameter of test, this may then generate multiple instances and be a more production-like platform that you deploy under the template. And you can also collaborate, so you can share these templates. So where you've got large distributed teams, you might be able to share snippets, share whole templates, and allow different parts of your organization to create a replica environment. And this is a basic snippet of a template that starts with a number of headers. You can fire in parameters at the top, which are used for user input. Do some mappings of things like drop-down lists to actual specifications behind the scenes, in this case machine images, resources you create, and outputs that might come back in the console as the stack is being created. Okay, so that's bootstrapping environments that would be tuned to your particular requirement, whether it be a Beanstalk, PHP environment, whether it be something highly customized using CloudFormation, whether it simply be a collection of software that you bundle into an AMI which enables you to create a workstation environment maybe for developers. But often we're tasked in an enterprise environment of dealing with packaged applications, and how do we test our modifications to those packaged applications, or test how a new upgrade to that application would behave in an environment where it's highly integrated, for example. So there's a number of packaged applications that you can run in AWS from different vendors, SAP, Oracle, Microsoft and IBM, for example. And just looking at a couple of those, SAP, for example, we have certifications to run a whole range of SAP environments within AWS, fully supported and certified by SAP. So if you think about the complexity behind running user acceptance environments for SAP, running test environments for SAP. Typically, they require quite a significant infrastructure investment to run the databases, to run the application servers, and so on. Moving those into AWS allows you to benefit from all that disposability and the numerous natures of environments that you can create based upon template, at the same time as reducing your overall costs. If you look at Oracle, if you go to the Oracle page on the aws.amazon.com website, you can launch AMIs here shown in this screenshot of popular Oracle apps. So if you want to launch PeopleSoft ELM, you can click Launch AMI and it will launch into your account and create an instance pre-configured with that version of that software. This enables you to bootstrap those dev test projects that are requiring you to customize your internal applications, or to test the integration of new versions of applications that normally come with a significant investment of time and effort to build that infrastructure. Third thing about taking lots of stuff from AWS when you need it is that you can run pretty much anything, whether it be a packaged application, as I just discussed, whether it be your own application containers for your own web-facing or mobile apps. But you can also run all the software and frameworks that you need to support the dev test cycle in AWS. So development and test frameworks in AWS, because AWS is open and flexible, enables you to run things like source control. So you can leverage EC2 to run popular source control systems and have those relying on things like our snapshotting and time snapshotting into S3 for backup and recovery. You can obviously add project management software and issue tracking software, popular software that you can download and install. You can also deal with some of the complexities around things like dependency management. So one of the challenges in development is that a particular workstation environment to support a particular aspect of a project might be configured differently from another, and that you end up with dependency problems on workstations. And you can build workstations for developers within AWS that are standardized, and you can spin these up and use them and allow remote desktoping into them, for example, to use a known configuration of workstation or user environment. And of course, EC2 has a significant amount of horsepower behind it should you choose to use it. And build servers running things like your unit and regression tests, you can significantly reduce the overall time to build, to test, and achieve continuous integration using elasticity of EC2. So let's have a look at a common pattern or a common environment technically of how people string things together within AWS. So on the left here we have local on-premise development team connecting to AWS through a VPN. And a VPN in AWS can run across the public internet, and we provide the hardware endpoints within AWS that you configure your local customer gateway to talk to, or it could be over a dedicated bandwidth connection using Direct Connect. But either way, you then running within a VPC that we saw earlier, and a VPC essentially means that all these resources are only available through that VPN gateway unless explicitly published to the outside world. And within that VPC, we can see here we've got a source control repository running on EC2, published under an elastic IP, so a known endpoint address. And that source control repository is backed by EBS storage volumes, and that those storage volumes can then benefit from being snapshotted into S3 for backup and recovery. We've also got project management tools, same pattern, but here we've got it backed upon an Amazon RDS, a relational database service. So a classic project management framework running against something like Microsoft SQL Server. This could be TFS in the Microsoft world, or it could be a Redmine running against a MySQL database. And then we've also got developers' remote workstations there at the bottom. So these could be configured environments such as Windows environments, Linux environments, different Linux desktops with different configurations. Might be for testing different types of browsers to interact with our applications, or simply different developer environments configured with different libraries to avoid complexities of dependencies and resolving those on a developer workstation. And that's a classic pattern of performing or installing the software to support the development test cycle within AWS. Talking about things like read mine, and in this case also a screenshot here of Perforce, you can use the Amazon Marketplace to launch pre-configured applications to support your dev cycle. So rather than having to download and install and configure an instance yourself, you can simply click in AWS Marketplace and launch it into your account. So this is a great way to bootstrap a particular project environment. So you might, in a significantly large environment, have localized project management and issue tracking software for a team, and you can create those within AWS with ease. Another pattern that I mentioned around building previously is that people use a combination of SQS, our simple queuing systems, shown here in the middle as a build queue, and our auto-scaling groups to support a parallelized view of building software. So here we've got a build queue where our project management tool might drop a message on that queue to say I've got a build ready to do, and that the builder instances pick up that trigger from the queue and pull source code from the repository, and then they'll run things like their unit tests, the regression test packs, and then build output dropped into S3. So here, compiled binaries, might be documentation, reporting, or what have you. Everything that comes as part of a build process, you can do in parallel based upon auto-scaling within AWS, and make that nicely asynchronous using build queues built upon Amazon SQS. So again, a very common pattern for parallelizing the build process and shortening the time to get to a result. So last part of, well, the penultimate part, sorry, of taking lots of it when you need it from AWS is testing at scale. So how does AWS help the test cycle? Again, there are many different types of testing, but some of the common things that people use AWS to perform are unit and regression testing, load and performance, A/B scenario testing, and security testing. So with unit and regression testing, quite often these things can take some time to run a large pack of unit tests, and the ability to scale up and run in parallel allows you to achieve the end result in a fraction of the time. And we saw that in the previous pattern. Load and performance testing, we have customers, and indeed there are partners on the platform that develop software themselves and sell it to third parties like yourselves, like BrowserMob, that utilize things like the spot market for generating load tests against a web application and testing how that performs. We also have customers using that sort of process internally to check how their applications respond using things like auto-scaling. So to generate enough load on something that they can check that their application scales in a way that they predict. We have other customers that would do A/B testing. So running a different scenario testing with replica stacks is something that you can do with ease within AWS, because you can simply create a carbon copy environment, load a different version of the application, and route traffic differently between those versions. And then lastly, security. So being able to create a sandbox environment, a real copy of production environments that you can target penetration testing or aggressive security testing against without disrupting your production systems. So thinking parallel, the first of those things, and the build servers, an interesting equation to bear in mind is that one instance for 100 hours will cost you the same as 100 instances for 1 hour. And if you took our small instances, that will cost you $8. So you can achieve significant parallelism at no extra real cost using AWS resources if you can achieve a parallel process. A/B testing that I mentioned before is the idea here that we have in the side that's labeled A, in availability zone A, we have an application stack with some application servers running in an auto-scaling group, backed by a master RDS database and a read replica there, with logs being shipped into S3 into a bucket, and the whole thing fronted by an elastic load balancer. Now with A/B testing, customers will create a carbon copy of that environment and launch it into a different availability zone. Exactly the replica, auto-scaling groups. They'll be using a read replica of the master database there, shown as the database R. Logs shipped into a different bucket in S3, but the application version or the AMI used to bootstrap those instances in that auto-scaling group will be different. And they were able to then use the load balancing to share the load between them and to check how things perform, how users accept those changes, what works, what doesn't. And that's one way of performing A/B testing. Rolling out to production, there are some pretty neat tricks you can play with AWS resources to make this quite easy and to have zero downtime deployments. The first of those is based upon a similar concept of you've just seen in that A/B testing. So using Elastic Load Balancer to, in this case, a load balance across a version 1 application running against an RDS, so a classic app running against a database, using an auto-scaling group there in my production system. And what you can do is you can bring on a new version of an application, V2 in this case, bring it into service with the Elastic Load Balancer, and then take out, once you're happy that V2 is running well, take out the instances running V1 from service behind the load balancer using the console or a command line. And then you can, when you're completely satisfied that V2 is running after a period of time, completely turn off or terminate the instances running V1, and now you're running on V2 application. And because we were using a load balancer, the load would have been distributed smoothly across those resources. Now another way of performing rollouts and indeed of performing A/B testing is to use our service called Route 53. So Route 53, shown here as the badge on the left, enables you to do weighted routing of requests. So shown here I have two application stacks, V1 and V2, each of these behind their own load balancer, and they're fronted by the DNS service such that in this case V1 is receiving 90% of traffic and V2 is receiving 10% of traffic. Now I can change those weightings, and they could be 99-1, they could be 50-50, they could be 100-0, and I can slowly move traffic from one application version to another, or back again if something's gone wrong, with ease using the control I have in Route 53 as a DNS provider within AWS. So a very similar way that you can do A/B testing is that you may send a 5% proportion of traffic to your new version so that 5% of users see something different. Okay, so back to my 3 points. We had take lots of it when you need it, throw it away when you don't, and preserve it for future reference. We've just talked about taking lots of it when you need it, so let's talk a little bit about throwing it away when you don't. It has been something that we've discussed in the previous slides, but let's draw it out explicitly. So the first thing to really understand in AWS is there are different types of instances. So there are on-demand instances where you pay a given rate per hour, and that you can request them, you'll receive that instance, you'll start being charged, and when you turn it off you won't. There are reserved instances where if you're running an instance for a significant proportion of time, you can prepay for that instance type and receive a reduced hourly rate. So you might have project management software, for example, that would benefit from running in a reserved instance because it's on all the time, versus something like an app server as part of a development environment that may be thrown away regularly that would benefit from being on demand. But at the other end of the spectrum, we have spot instances, and spot instances allow you to bid on unused EC2 capacity, and you'll have a particular market price for that is normally significantly lower than the on-demand price. So this is useful for things that you have a flexible start and stop time around the processing, or that you can tolerate some sort of breakage in that process if we reclaim that resource. So it could be used for very large scale load testing, where you might spin up hundreds of spot instances running scripts to generate load on your web application. It could be used as build server excess capacity, so where you have particularly heavy build loads, you might use spot instances to fill the gap at a reduced price. But the primary thing really is to consider turning stuff off when it's not in use. So a traditional development or test environment will be on all the time, and it will be incurring the cost of running that stuff, and it will also be meaning that you can't use it for anything else at that given time. And the real basics here within AWS is turn it off when you're not using it. So if you look at this particular load on an environment, if I were to reduce it by half during the times to the left and the right of this chart, I would save 25% on my costs. Now, looking at another way, if I have a development team that works from 9 till 5 or 10 till 4 with a 2-hour lunch break, depending on what sort of work environment you're in, if you simply turn things off entirely overnight, and turning things off in AWS means that they're stopped, you're not paying for them, but they can be started again when required, is that you would save, let's say, 50% or more of your costs of running a dev test environment. Now, that could mean for the same budget you can run twice as much and get twice as much done, or try twice as many different approaches to solving a particular problem or innovating on behalf of your customers. So auto-scaling is a method you can do this. So you can use auto-scaling to set a schedule, and you might set that schedule to turn off at turn on here at 7:30 in the morning and turn off at 7:30 at night a bunch of resources, whether it be a proportion of the resources or all of the resources. And that can yield you significant cost savings. Now, you can create quite a lot of things in AWS, so you can take as much as you like, and you truly can. And one of the biggest sort of learnings is that AWS creates a huge amount of agility for development teams, and when you empower them to create environments, to try new things and deploy new software, they will. But typically they won't turn it off. So as a reminder, imposing some sort of strategy around making sure environments are cleaned up will be an important part of your cost containment. So you'll get agility and cost optimizations at the same time. So you can truly create a supercomputer in the cloud, whether it be in one single click of a deployment or over time as you build it up. So do remember to turn it off at the end of the day. Some of our customers indeed have dashboards within their development environments that is using the AWS APIs to pull the number of running instances, and they're targeted on the fact that when they go home they should be turning off environments or stopping environments to keep that instant count low, because that directly results in cost savings. Okay, so take lots of it when you need it, talk through that and how you create environments, throwing it away when you don't, and cost optimization, so quick thoughts on different types of instances that you might use for different types of jobs, and the fact that turning things off is your fundamental lever in maintaining your cost and agility ratios. But a last point which I mentioned up front is about preserving things for future reference, and this is quite unique to the cloud because you can do this extremely easily within AWS. So disposable environments that we just talked about can be recreated if you think about the way that you save those environments for future use. And we've touched upon different mechanisms for doing that, but it's worth drawing these back together at this point in time. So you dispose of them for cost optimization reasons, that you just want to get rid of them when you're done, but you can preserve them or preserve critical points in time along your development cycle so you can recreate them. And the first tool in that armory is AMIs. So customers will recommend creating a catalog of AMIs for each iteration of an application and storing those in S3. The storage costs of an AMI is relatively small, compared to the benefit of being able to go back to any particular point in time and recreate that exact environment on a machine running within AWS. Likewise, you can do the same with data or disk images associated with your applications, their environments and their deployments. So EBS, the Elastic Block Store, allows you to save an image into S3, which is essentially a frozen data set, and then you can reconstitute a volume from that snapshot and attach it to an instance when needed. So this might be particular test data sets that you might have in a catalog that enable you to go to a particular test case at any particular point in time and see how that's evolved or not, and rerun that test case to find a particular problem. And then lastly, templating. So using CloudFormation, I've mentioned this before, that you can source control the infrastructure specification that comes with a particular application version. And if you're programmatically generating a CloudFormation template, that will come part and parcel in the build process, so that for every application version you deploy, whether it be every minor or every major, there is a specification so that a year down the track, if you need to recreate that environment, you can simply pull the template and launch Stack with a single click in the console and have that built an application running with all the specification that you require. So you can essentially roll back and recreate an environment for any given application version at any given point in time. And that has benefits for whether you're looking at recreating a problem in a SaaS application, whether it be a packaged application or some back-end service. The benefits from a supportability point of view are quite obvious. So another company that's using AWS significantly across the board, but primarily in their development and test environments as their starting point for using AWS, is Shell. So Shell started using AWS in 2010. They've gone through the process of what they call operationalizing their cloud strategy. So not only having a strategy of using cloud, but internalizing it into all the processes, the controls, the ticketing systems in order to generate environments upon demand. And it's part of their Shell Foundation platform, which is a framework. So AWS is an approved part of that foundation platform. So not only have they got core operational applications running in production on AWS, but they have dev test environments. So the ability for them to create an environment on demand based upon some business requirement and flush it through their ticketing system such that out pops an environment as needed by a particular team to achieve a particular goal has been really systematically built in using AWS APIs and integrated into their internal platforms. So they've got pretty slick on creating environments and then destroying them when they're done and also preserving them, the three aspects that I've talked about. Now, obviously, the benefits that they talk around here are the fast provisioning primarily, so it can be within minutes for most applications and needs, and it's elastic. So they're able to create it on demand as they require it. It's always there, and they can get rid of it when they're done. So they talk about an organization the size of Shell gaining real business agility because of this. So they're able to deploy services more quickly. They're able to say yes to development teams, or development teams are able to say yes to businesses when they require some sort of environment to do work, rather than maybe having to wait for resources to be freed upon internal platforms, or the procurement and provisioning of a server to run a particular environment come about. Okay, so we're drawing to a close on today's webinar. So where can you go next for more information? So first that I mentioned previously was our TypePad blog, so aws.typepad.com. You can go here and you can subscribe using RSS, and you will receive notifications in your inbox of all the new features and services as they come. So whether you're looking to find out when new containers for Beanstalk are coming, when new features in CloudFormation, a particular type of application might be available in the marketplace, you'll find it on this blog. The other place to look is aws.amazon.com/whitepapers. There is a host of information here of whether you're looking to run a packaged Oracle application on AWS, and that might be part of your test strategy that you're looking to achieve, whether you want to spin up a SharePoint environment for testing that in your infrastructure, or you're looking for best practices on architecture and automation. There's a whole host of white papers there, and do go back to that page regularly because there are white papers being added all the time. So summary of today's discussion really is that cloud makes development and test easy. You can leverage the elasticity of cloud to make extensive savings in terms of cost of running infrastructure within AWS as opposed to traditional environments. It also provides some unique tool sets to help you manage and create environments. So whether it be Beanstalk, whether it be CloudFormation, whether it be Amazon Machine Images or the snapshotting you can do, it enables you to reconstitute environments really quickly at a click of a button. And that lets you perform at a scale of operations in terms of parallel operations, and also agility beyond the things that you could do with traditional physical environments, simply because in a busy development environment, your resources are contended for that physical equipment. You only have so much capacity for running dev workstations in a virtualized environment, or only so much capacity to spin up a number of parallel environments for a number of parallel sprints that you might be performing around an application, for example. Lastly, you can get started with Amazon for free. So if you want to try any of these or spin up a container to try testing an application in the cloud, you can do so on instances sizes under our free tier. You can use the database service, relational database service, you can use storage and S3. There's quite a significant list of services that you can use for free for 1 year. So if you don't have an account already, sign up at aws.amazon.com/free and get going.